Hello everyone! Welcome to this video, and today we will be learning how to calculate reaction forces applied to a structure at the supports. I am so glad that you could join me today, and I'm very excited about today's topic. So, have you ever heard equilibrium and support reactions? If you haven't know it yet, just keep on watching and listen.
So in figure 3.1 letter A, we have this problem. So M is the total number of members in the structure. The R is the number of reaction components. J, the total number of joints in the structure. And EC is the number of equations of condition. So dito, meron tayong dalawang members. Yung members natin is equal to 2. 1 and 2. Yung reaction natin is equal to 3. Reaction 1, reaction 2, and reaction 3. Yung number of joints natin dito na structure is meron tayong tatlo. 1, 2, and 3. Yung number of condition natin is 0. So, using formula 3M plus R is equal to 3J plus EC. So, 3 times the member 2 plus the reaction 3 is equal to 3 times the joint 3 plus the EC, wala tayong EC, so 0. So, 3 times 2 is 6 plus 3 is equal to 3 times 3 equals to 9. So, 6 plus 3 is equal to 9. So, 9 is equal to 9. So, this is internally stable and it is statically determinate. So, letter B. We have the members of structure 1, 1, and their R reaction is 5, 1, 2, 3, 4, 5. The number of joints is equal to 2, 1, 2, and our number of equations of condition is equal to 0. So, using the formula 3M plus R greater than 3J plus C. So, 3 times the number of members, 1, plus the reaction, 5 greater than 3 times joint, 2, plus REZ is equal to 0. So, 3 times 1 is equal to 3, plus 5 greater than 3 times 2 is equal to 6. So, 3 plus 5 is 8, greater than 6. So, this means that internally stable with the reaction of 5. So, it is statically indeterminate. So, in letter C, we have hinge. This is the FBD. We should identify the numbers of members in the structure. In this structure, the reaction components, the number of joints in the structure, and the number of equations of condition. So here, meron tayong number of members 4. 1, 2, 3, and 4. Our reaction is equal to 6. 1, 2, 3, 4, 5, and 6. The number of joints in this structure is equal to 5. 1, 2, 3, 4, and 5. So, our number of equations, meron tayong hinge. So, meron tayong number of equation 2. So, 1 and 2. So, applying the formula 3M plus R greater than 3J plus EC or C. So, plug in natin. 3 times the number of member, 4, plus the reaction 6, greater than 3 plus join, plus 2. I mean 3 times 5 joint plus 2. So 3 times 4 is 12 plus 6 greater than 3 times 5 is 15 plus 2. So 12 times 6 is equal to 18 greater than 15 plus 2, 17. So in figure letter C, 18 greater than 17. So this structure is statically indeterminate. So in figure D, we have also hinge. Identify na naman natin yung numbers of members, their reactions, the number of joints, and the equation of condition. So here, mayroon tayong number of members na 2, 1, and 2. Our reaction is equal to 3, 1, 2, and 3. The number of joints natin is equal to 3, 1, 2, and 3. So, yung number of condition natin is equal to 1. Ito, yung hinge. So, using formula 3M plus R less than 3J plus C. So, 3 times the number of members, 2, plus the reaction, 3. So, 3 less than 3 times 3, the joint. This is the joint, 1, 2, and 3, plus the EC or the C1. So, 3 times 2 is equal to 6, plus 3, less than 3 times 3 is 9, plus 1. So, 6 plus 3 is 9, less than 9 plus 1 is equal to 10. So, this beam is statically unstable. 3.2 internally stable with reaction is equal to 5, so it is statically indeterminate. Letter B, internally unstable with reaction is equal to 5, and equation of condition is equal to 2. So the beam shows statically determinate. Letter C, internally stable with reaction is equal to 6, so it is statically indeterminate. Letter D, internally unstable with reaction is equal to 6, and the equation of condition is equal to 1. So the arc shows statically indeterminate. Letter E, internally unstable with reaction is equal to 5, and the equation of condition is equal to 2. So the frame shows statically determinate. 3.3, letter A, internally unstable with reaction is equal to 5, and equation of condition is equal to 3. So the beam is statically unstable. Letter B, internally unstable with reaction is equal to 4, and equation of condition is equal to 2. So the beam shows statically unstable. Letter C, internally stable with reaction is equal to 4, so it is statically indeterminate. Letter D, internally unstable with reaction is equal to 4, the equation of condition is equal to 2, so the frame is statically unstable. So, the number of members is equal to 1, our reaction is equal to 4, 1, 2, 3, and 4. So our joints is equal to 2, 1, and 2. So the number of equation is equal to 0. So using formula 3M plus R greater than 3J plus C. So 3 times the number of members, 1, plus 3 times the number of member, 1, plus the reaction 4 greater than 3 times that joint, 2, plus 0. 3 times 1 is 3 plus 4 greater than 3 times 2 is 6. 7 greater than 6. So this is statically indeterminate. In figure B, we have M is equal to 3, 1, 2, and 3. Reaction is equal to 4, 1, 2, 3, and 4. Our joint is equal to 4, 1, 2, 3, and 4. And our number of equation is equal to 2. The hinge, 1 and 2. In formula, 3m plus r less than 3j plus c. So 3 times the number of members 3 plus the reaction 4 less than 3 times the number of joint 4 plus the equation of condition, which is the number 2, plus the number of equations of condition 2. So 3 times 3 is 9 plus 4 less than 3 times 4, 12 plus 2. Then 9 plus 4 is 13 less than 12 plus 2 is 14. So this is statically unstable. So we have figure 3.31. We have, so the summation of moment B is equal to 0. So negative AY times 24 plus 30 times 12 times 18 plus 200 times 10.4 is equal to 0. So AY is equal to 356.67 kilonewton upward. So the summation of moment in AC to C is equal to 0. AX times 12 minus 356.67 times 12 plus 30 times 12 times 6 is equal to 0. So A of X is equal to 176.67 kilonewton. So the sum of forces in X direction is equal to 0. 176.67 minus 200 plus B of X is equal to 0. So B of X is equal to 23.33 kilonewton. So the sum of forces in Y direction is equal to 0. 356.67 minus 30 times 12 plus BY is equal to 0. So BY is equal to 3.33 kilonewton. So this is the free body diagram. So in figure 3.32, we have the free body diagram. So our solution is the summation of MAC to C is equal to 0. So negative AX times 24 minus AY times 48 plus 50 times 8 is equal to 0. So 3AX plus 6AY is equal to 50. So the summation of moment MB is equal to 0. Negative AX times 12 minus AY times 76 minus 50 times 4 plus 125 times 14 is equal to 0. So 6AX plus 38AY is equal to 775. So solving for 1 and 2 simultaneously, so we obtain A of X is equal to negative 35.25k, so equal to 35.25k. AY is equal to 25.96k. So the summation of forces in X direction is equal to 0. So 35.25 plus 50 minus B of X is equal to 0. B of X is equal to 85.25k. The summation of forces in Y direction is equal to 0. 25.96 minus 125 plus BY is equal to 0. BY is equal to 99.04k. In figure 3.35, we have the free body diagram here. We have hinge, So solution, the summation of moment MB is equal to 0. Negative AY times 24 minus 20 times 12 plus 1.5 times 16.97 times 18 plus 1.5 times 16.97 times 6 is equal to 0. So AY is equal to 15.46K upward. So the summation of moment in AC to C is equal to 0. Negative A of X times 24 minus 15.46 times 12 plus 20 times 12 plus 1.5 times 16.97 times 6 is equal to 0. So A of X is equal to 8.63K. So the summation of forces in X direction is equal to 0. Negative 8.63 plus 20 minus B of X is equal to 0. B of X is equal to 11.37K. The summation of forces in Y direction is equal to 0. 15.46 minus 2 times 1.5 times 16.97 plus BY is equal to 0. So BY is equal to 35.45K. So in figure 3.31, we have the free body diagram here. So considering the free body portion. So CY times 30 minus 2 plus 1 times 10 times 5 minus 36.06 plus 18.03 sine 33.69 degree times 15 plus 36.06 cos 33.69 degree times 22.5 minus 18.03 cos 33.69 degree times 7.5 is equal to 0. So RCY is equal to 1.25K. So the summation of moment is equal to CE to E is equal to 0. Negative C of X times 20 plus 1.25 times 15 plus 2 times 10 times 15 plus 36.06. So 18.03 divided 2 is equal to 0. C of X is equal to 32.19K. The summation of forces in X direction is equal to 0. Negative 32.19 plus 2 plus 1 times 10 plus 36.06 plus 18.03 sine 33.69 degree minus 0x is equal to 0. Sine 33.69 degree minus d of x is equal to 0. So d of x is equal to 16.25K. So the summation of y forces is equal to the sum of forces in y direction is equal to 0. Negative 1.25 minus 36.06 cos 33.69 degree plus 18.03 cos 33.69 degree plus dy is equal to 0. So dy is equal to 16.25K. So here's the FBD or the free body diagram. Free body portion AC. The summation of X forces is equal to 0. 32.19 plus 2 times 10 minus A of X is equal to 0. So A of X is equal to 52.19K. The summation of forces in Y direction is equal to 0. So negative AY plus 1.25 is equal to 0. AY is equal to 1.25K. The summation of moment of A is equal to 0. So M of A is minus 32.19 times 10 minus 2 times 10 times 5 is equal to 0. So M of A is equal to 431.9K per point feet. Free body portion of BD, the summation of X forces equal to 0. 27.81 plus 10 minus B of X is equal to 0. B of X is equal to 37.81K. The summation of y forces is equal to 0. By minus 16.25 is equal to 0. By is equal to 16.25k. The summation of moment MB is equal to 0. MB minus 27.81 times 10 minus 1 times 10 times 5 is equal to 0. M of B is equal to 328.1 k point feet. So now we have worked through a few simple examples for calculating support reactions, and we have seen how we can apply the theory we learned at the start. So thank you for watching.